Hello everyone and very good morning to all of you. So this is your practice session where we'll be discussing all the PYQs from 2002 to 2024, even 2025 JEE Main PYQs as well. Like this year questions which appeared in the first attempt of JEE Main January attempt, we have those questions also in periodic classification of element. So one of your 11th standard chapter will directly start it with topic wise topic will go, and we'll try to cover whole chapter and their PYQs based on the topics actually. So individually, if we start the chapter of periodic classification of element, the first thing that comes as a topic is the periodic table and its feature. So we'll start the questions from there. Let's start the first question, everyone. This question appeared in JEE Main 2025 this year itself, and I guess this was related to some statement 1 and 2, true false kind of question. Let's start. So given below are two statements. Statement 1 says that according to the law of octaves, you remember the law of octaves, Newland's law of octaves he's talking about, the elements were placed in the increasing order of atomic number. So I guess this is incorrect. This is a false statement. If you remember, they were arranged in the increasing order of their atomic mass. Okay, and then Mayer observed a periodically repeated pattern upon plotting the physical properties of certain element against their respective atomic number. And again, this is what is it asking, that the plot was observed there in Luther-Mayer curve he is talking about. Okay, but we remember that all the physical and chemical properties were shown in a periodic function of the atomic mass rather than atomic number. I personally think this is also a false statement. So both of the statements over here are false. One of them belongs to the law of octaves, another one belongs to the Luther-Mayer curve, and both of statements have been over here are false. So that was a question from JEE Main 2025. We have another question from 2024, JEE Main 2024. The question came as a statement based question, but right now we have some statements also. Read it out fast, quickly attempt it and submit your answer. And if you face any kind of doubt, do let me know in the comment section. I'll help you out. Question, statement 1. In the group 13, the stability of positive and oxidation state increases down the group, and this is true due to inert pair effect. Due to inert pair effect, the positive 1 oxidation state becomes more stable than positive 3, which is a true statement, by the way. And then we have the atomic size of gallium is greater than that of aluminium. So that we have to discuss basically. Boron, aluminium, gallium, the size was like increases, but size decreases here because of the insertion of d subshell. So this is a false statement. So one is true, another one is false. What could be the correct answer here? Statement 1 is correct, second is false, B is the correct answer. So that's how we do it. Hopefully all of you are getting what I'm trying to explain. And if not, do let me know in the comment section. Okay, let's suppose some of the students of you are like now watching this lecture after this, not lively you might be watching, and right after the finishing of this lecture you may watch this lecture right after some day. Then in comment section you will post your doubt. We respect all the doubts coming from student side, and we'll basically respond you on that. So now let's come to the okay, that was the correct answer, by the way. JEE Main 2024, another question is here, everyone, and we all know this is a very easy chapter. And why do I keep on calling it an easy chapter? Because see, it's a most fundamental and basic chapter for inorganic chemistry. So those of you have not undergone this chapter till now, maybe you are preparing for 2026 or 2027, but this is the most important time that you should cover. Even if you are in 11th or 12th or dropper, you have to cover this chapter because it's very important chapter and a basic fundamental chapter for complete inorganic chemistry. Let's have another question. We have some set of elements over here, and those elements have to be matched with the given number property. So the property simply says what? Okay, we have to first identify the property, then we have to go to them. Elements with highest electronegativity. You know what highest electronegativity are? Phone, fluorine, oxygen, nitrogen. So D belongs to first. See how easy. And then next is element with the largest atomic radii. So francium and radium are supposed to have the largest atomic radii. Then elements which show the properties of metal and non-metal, metalloids. Germanium, arsenic, both of them are metalloids. And lastly, we have elements with highest negative electron gain enthalpy, which is chlorine and sulfur. So the answer is this. Anyways, it was an easy question mostly. Hopefully you all have got it and you can apply all the concepts I taught you in my previous session of previous session of its theoretical explanation, conceptual session. And I also introduced, I remember, a few of the questions to practice upon. And but here we are right now having the complete analysis of the JEE Main, how the questions have been asked and how many number of questions have been asked on a particular topic. And I found that these number of topics which we are right now doing, these are the MVP, most viable product, as in they have been asked so many times. They have been asked like literally many times throughout the examinations. Okay. JEE Main 2024, we have another question. So guys, in 2024, 2025 up to like 2021, we had plenty of shifts happening there, and that is why so many questions you might see upon a single topic in just single year. It's not a, like a one paper kind of question, like it did all of these questions were in one paper. No, they were like shift wise, they are segregated here. So now let's come back to the question. Question simply says, number of elements from the following cannot form compounds with valencies which with their respective group valency is. Okay, respectively group valency is in what is the common valency over here. So let's say if I, okay, we have boron carbon atom here, means we are group 13, 14, 15, 16 and 17. So their usual valencies are, if I talk about their group valency, so this is 3, 4, 5, 6 and 7. So these are the basically valencies shown by respective group. And which element do not show these and belong to the same groups are carbon shows 4, boron, aluminum both shows 3, nitrogen. Nitrogen usually shows a valency of 3. Oxygen shows a valency of usually 2. Fluorine shows a valency of 3. And if it could have been chlorine can show its valency up to 7, forming ClF7. So that's what this question is all about, that which of the elements. So these are nothing but the second period elements which can differ. Second period elements, and that too from there. So I think 3 should be the correct answer, and we have to check what the correct answer is. No idea on the answer, but yes, it will be definitely correct. If you know and you apply the concept very well, then definitely the answer will be correct. Okay. Am I audible first of all, if you know? Am I audible first of all? Oh, I am pretty much audible. Thank you guys. And guys, please keep on liking the session. Those who are right now attending the session, please keep on liking the session. It gives us another, what should I say, a confidence and in a proper feedback to the teacher that what content are we providing, are you guys liking it or not. So do let us know by liking the session. Okay, now I'll take you to the next question, also appeared in 2024, and the question is pretty simple. Says that we have plenty number of elements and we have to match their electronic configurations with, okay, nitrogen. So nitrogen is 3s2 3p3, okay, 2s2 2p3. So nitrogen first has third. Okay, so out of these all, only one option has first has third. So what I'm trying to say is, this kind of method, what I'm right now applying, is called as option elimination method, where we are not supposed to look into all the options. We can simply take one which we know, and if it is the only option which we find correct, then we can move ahead rather than checking the others. Okay, so this is absolutely correct. A, we have the C as answer. Only one answer, only one matching gave us the correct answer. We have to learn these tricks. These are called as option elimination tricks, and you must know about it because it is going to save plenty of time of yours in your mains and advanced examinations. Next question we have. Okay, so in this today's session, guys, I didn't tell you, but there are plenty of questions, around 150 questions we are going to deal with, and that's why you might have seen me, I'm going a bit faster. So I am planning to cover everything into coming 3 to 4 hours, where I'll be covering around 150 questions came from 2002 to 2024, and also I have included the questions from 2025 as well. Okay, and this will definitely help us. This round of practice will definitely help us to do the exact parameters of the practice that we right after this lecture you won't require further practicing upon this particular concept. If you want to do it for, you can also try for advanced, and for advanced we'll definitely bring the questions and practicing part. For 2025 we are also bringing the advanced session right after your JEE Main attempt, April attempt, and then for 2026 people we also are bringing our advanced sessions very soon, including some questions and practicing of advanced question. But concept what we teach you is always up to the advanced level. So always you can grab the all the notes from our side. You can download the PDF which we share usually on our Telegram channel. Link is given in the description. Right now, join it, okay? And right after downloading the notes, you better make your own notes, and these notes should be very much, do you know what? Systematically and roadmap. It should be a roadmap kind of thing. Like you should remember where what topic comes first and what next, and like that. That is going to help you. Anyways, now let's come back to our topic. So we were discussing that about the IUPAC naming of unantrium or unanium, this triple one, I guess. Oh my god, this is very easy question. So the value of n is unanium. This is triple one actually, triple one. Very easy question. This whole chapter is quite easy. Okay. Hopefully, we right now having one more question from JEE Main 2024, but the answer is already given as third. But we'll see it. It's just a simple electronic configuration that we have to match. For chromium 2 plus it will be 3d4. So we can simply pick it to 3d4. Chromium has 24 atomic number, and the electronic configuration is argon 4s2 3d4. And after removing of 2 electrons, it will become 3d4. Okay. And even if it's in its excited state of 3d5 4s1, if after removal of 2 electrons, it will become 3d4. Nickel 2 plus will become 3d8. d8. Now check out. No, not like that. This is d8. So C has 1. We have two options of C is 1, and we also found A has 3. A is 3. That is only one option. First is the correct answer. Okay. Let's have another important question, guys. This is a very important question, and I've seen this question plenty of times in even in P block somewhere, and in this modern periodic table as well. So guys, my suggestion to everyone who is going to start inorganic chemistry and going to learn all the block chemistries, S block, P block, DNF block, the very fundamental chapter is your periodic classification of element. This is the chapter that you should cover anyhow, because right after coverage of this chapter, it will be very much beneficial for you to cover the rest of the chapter, because plenty of things, even majority of the basic concepts will be used from the periodic table itself. Their periodic properties, physical, chemical properties, atomic properties, and chemical properties as well. There are like lots of things which are like very much common. Let's come back to the another question. We have the given are two statements. One of them is labeled as assertion, another one is labeled as reason. We have to find out whether assertion and reason are correct or correct explanations or not. Assertion says that H2T, so we move from oxygen, sulfur, selenium, tellurium. So H2T is more acidic, which is true because easily hydrogen can be departed because of the low bond energy of H2T, which is a correct explanation as well. So I think the correct answer should be A. Okay, so you can also pick your respective answer, everyone. I am expecting you people are also practicing by your end, and in case you don't get anything and you have any doubt, do let me know. I'll definitely help you out of this confusion. The anomalous behavior of oxygen is due to, why does oxygen behave anomalously? That is all because of its small size and high electronegativity, and that makes it like oxygen majorly has ionic compounds. Oxygen usually has valency of 2 and doesn't make number of bonds beyond 3. And you might have seen it is in like hydronium ion, it makes 3 bonds with hydrogen, but not beyond that is possible. But if to talk about sulfur, sulfur has SF6, it can extend its covalency. So why are these things? And this is all because of its small size, high electronegativity, that makes it oxygen different than the rest others. And have you ever come to this fact that sulfur has higher electron affinity than oxygen? Because oxygen, because of its very small size, repels the incoming number of electron, and that makes oxygen has lesser electron affinity. So B, I think, is the correct answer, which was a very easy question basically. This question can be counted in P block also. In group 16 we study these topics and these properties, but mainly this is your modern periodic table, and it consists of every single thing that we are gonna to study in the block chemistry. Now, what is the difference between block chemistry and periodic table is when we'll be dealing with the block chemistry SPDF blocks, there we have some important compounds of the these elements, but in JEE Main point of view, this topic has been eliminated out. The properties of the compounds and important and their preparations and all. This has been removed out by JEE Main. So now, if you study very well this chapter, modern periodic table and periodic classification of element, in this whole chapter, it's very much useful to you in your block chemistry, because block chemistry, the part which was already eliminated out, is now not in your use, and that is, and rest of the things you will study in the modern periodic table itself. Okay, now come back to the question. Question says that both metal and non-metal exist in P and DA block. So let me check if it is right. D block, all are metals actually. All are metals. So this is a false statement, I guess. Both metal and non-metal do not exist in P and D. And non-metal have higher ionization enthalpy. Non-metals have higher ionization enthalpy, right? Because metals easily can lose electron, and that's why they are metallic in nature and higher electronegativity than metals. I think this statement is true. One is false, another is true. What do you think? False, true, false, true, false, true, false, true, false, true, false, true. C is the correct answer. Questions are pretty easy, man. Like, I see these questions and some notification come in my mind. Oh, this is the correct answer. Pick it. Why am I calling this? Because inorganic chemistry is not just the easiest, but it is also very time-saving subject to all of us. Inorganic chemistry majorly contains those kind of questions in which either you opt the correct answer or you don't. So it's saving your time. Either you know the answer, you'll get it +4. If you don't, then you will leave it. You will not go for a fluke, and that is why it saves your time. Coming to the physical chemistry, you will first of all try to do this question, and this attempting of the question also requires some time. So it may waste your time if you don't know the concept, and if you don't know the correct answer and you don't reach to the final milestone, it will definitely waste your time. But this doesn't happen in the case of inorganic chemistry. Try this question, by the way. Which one of the elements will remain as a liquid inside pure boiling water? So first of all, let me just know this timeline. Where did I say this thing? I'll make a shorts out of it. Which of the following will remain as liquid inside pure boiling water? So if there's a pure boiling water, then lithium, bromine, cesium, gallium, inside pure boiling water. So actually, what is this question about? In the pure boiling water, we would require an element that has low melting point but high boiling point, and gallium could be the correct answer, because gallium is the one which is like remain liquid inside pure water, because see, lithium and cesium might react with water producing some respective compound. Gallium doesn't interact with water as such. I guess this might be the reason. And we also know that gallium has a very low melting point and high boiling point as well, and it is used in some high sensitive and very high temperature range thermometers also. Okay, gallium. Let me see the correct answers. I think gallium is correct. Okay, we'll move next to the JEE Main 2023 next question. Okay, don't get confused about gallium and so many properties which we haven't heard of about this 13 group 13, because when we'll study the group 13 in P block, then we'll come to know about gallium and at its more specific properties. Okay, so we can rely on that question. We can skip the question as of now. It's a group 13 question. Let's come to the another question. We have some set of atomic number. We are going to match what group, what block they belongs to. So whenever you want to identify this part, my suggestion is either if it's a big number, as in like beyond 50 or beyond 60, you have to subtract there by no, it's like beyond 60 or 70, 72 in fact, it is beyond 71, then you have to subtract 32, and because lanthanum starts from there, lanthanide start from there, and if it is like lesser, it's like 50, 60 kind of 40 kind of thing, and remove 18 electron out of it to find out what nearest electronic configuration comes up with, or nearest atom element will be what. So let's suppose 37 is asking me. So 37 minus 18, if you do, it comes up as 19. And 19 is what? 19 is your potassium. Potassium comes to S block. So this is your, see how easily I found it. Without even anything writing up on the board. We have, let's suppose 78. So 78 minus 32 will be how much? 78 minus 32. 32 will be 46. 78 minus 32. 46. Then do 46. 46 minus 18. 18. So guys, are you sure? 78. Where are you lagging? Oh, this is 14. 14 is what? Silicon. So silicon is your group P block, by the way. No? So like that we have to do it. No? You can try this question by your own. I think it is an easy question. A belongs to fourth, and option elimination will be applied. These two will be cancelled out, and this two will be taken. But B has 3. B has 3, and I have B has 1. So B has 1 nowhere. How is it possible? Yeah. B will definitely come to 1. Yeah. B is showing second, which is D block. 78 cannot be D block. Okay. Yeah. My bad. This is correct, but when we talk about 78, we must know that all the elements of 72. Nahin yaar. I think we mistakenly took we mistakenly chose incorrect calculation there. 28 is for your nickel. It is nickel, so it's a D block. Now we are right actually. So this is second only. Correct answer should be C. Again, guys, it's an easy question only. It's all depends upon your presence of mind. So like I'm doing these questions lively over here, and that's why this kind of confusion may arrive, but still be confident about the option you are picking, because ultimately I reach to the correct answer only. And even if we check it, correct answer is C. Okay, try the another question, guys. Please try the another question. Came in JEE Main 2023. 23, 24, 21, 22. These had so many shifts, and that's why so many number of questions have come. Try this. So please try this question, guys. Allow me a moment. Yeah, so I got an urgent call, guys. Beg my pardon. Come back to the question, and we have this question that bond dissociation energy of EH bond in H2. Okay, H2O, H2O. So what does it follow? Will move down the group, and the bond energy will decrease, isn't it? Bond energy decreases, bond length increases. So correct options are what? Tell me. D has the lowest, A has the maximum. D has the lowest, A has the. I think this is the correct answer, guys. What do you think? Oh, yeah, very easy question. Yeah. Why JEE Main asked these questions? Yeah, 2023. Next, from again 2023, we have another question. Now, this is somewhere very typical question. I would like to share the feedback of these questions. This have been asked in 2024 also, 2023 also. And based on several properties, these questions have been asked. These are lanthanides, you can see in front of you. These are lanthanides. And their electronic configuration is very difficult to understand, to learn in fact. So I would like to suggest you that you better rote learn it and just keep things in your mind, and especially this thing has to be in your mind that which elements have D7 configuration, and these are gadolinium and europium. I guess europium and gadolinium has D7 configuration. I also come up with the this NCERT data is over here of electronic configuration, so that you can learn it immediately. Okay, so let us suppose we are right now having just lanthanides. So in lanthanide, europium, you see 6s2 4f7, 6s2 4f7 1, and then gadolinium also is 4f7 and 6 4d1. Rest where anywhere you can check it, it is d6 d5 d4, it is d9 d10 d11. So that two elements are very important, guys, europium and gadolinium. Please learn it immediately and you will get your answer. I think no further explanation is required, because it's it's not even a application based question, it's just a rote learning part of question. Next question is the IUPAC name of the element which has electronic configuration of radon 414 blah blah blah. So first of all, we need to write this properly just to understand which element right now we are talking about, and the atomic number we can know. So how do you can do it? You first find out the atomic number by simply summing all the electrons over there. So what is the atomic number of radon? See, helium, neon, argon, krypton, xenon, radon. So radon, oxidation. So oxidation has 118, subtract 32, 86. This has electronic configuration 86. So electrons are 86 plus 14 plus 1 plus 2. Total electrons are how many? These are 14. Okay. Anyways, it's a D block element, I know for sure. It's a D block element, but we have to identify its atomic number. So it is fine, no? Just add them up. This is 317, 103. So it will become what? Uniltrium. Uniltrium is the correct answer. Uniltrium. Uniltrium is the D option. See, there could be several ways you can also apply your mind. You can even identify which element are we talking about. But still, I found it the easiest method to calculate it out. Okay. Hopefully you all are enjoying the session now. And guys, as I told you, please keep on liking the session. That gives us more motivation. Okay. We have another question here. There is an element E which belongs to 4th period and group number 16 of the periodic table. The valence shell electronic configuration of the element which is just above E in the group is what? Okay, first of all, we have to find out what it is asking. Some belongs to group 16. So oxygen, sulfur, selenium, tellurium, polonium, and oxygen start to 2nd period, 3rd period. So these are all group 16 element. 2nd period, 3rd period, 4th period, 5th period, 6th period, like that. So group 2nd, period number 4. So first of all, we are talking about the selenium. Then it is saying an element which is just about to it is sulfur, I guess. And what is the electronic configuration of sulfur? Argon, no argon. It's neon, because 16 is the atomic number. No, neon 10, 4s2, 3s2, and 3p. 4 is the correct answer. So 3s2, 3p, 4. I think A is the correct answer. So see, guys, how easy is this question? Right, these questions have been asked in JEE Main, and I guess I personally advise all the students that don't go for any extra efforts. Sometimes students go to schools, they also go to, okay, let me come back to the topic. So here is the advice for all the JEE Main aspirants. They do a lot of hard work, they go to school, they go to coachings, they come back. Sometimes their examinations clashes in center or exam center. In the coaching center, there is a different exam going on, and in your schools, some different topic is ongoing. This kind of confusion make every time every student very irritating. So I would like to suggest one thing to every one of you, that if you are right now only planning for JEE Mains and you want to ace your chemistry in that, it's a better suggestion that you should apply, you should start doing NCERT very well. Because I found mainly of the questions came from NCERT itself, and the concepts of NCERT in chemistry, specifically about chemistry, I have no more depth about physics and mathematics talking about NCERT and the content that has been asked in exam. But yes, in chemistry, whatever the content you study from NCERT, that has been applicated in the examination of JEE Main. So I don't require any further, too many books are there, too many modules you're following, too much of the notes you are having, and then at final of the day you didn't do anything in the like you couldn't complete your syllabus. So that is going to basically reduce your marks, and that is not a very beneficial thing in JEE Main. In JEE Main you have to know about everything, and right now the pattern, it has like NEET and JEE Main are exactly at the similar level, I find, and questions are more, time is less. That is how you have to apply your time. Coming back to our question, we had another question from JEE Main 2021. In 2021, the question was asked is, there are like some of the elements are there and we got to match them with your group. I don't know how they are giving it as an ion. Group doesn't change. Actually, group 3, what is group 3? Do you know about group 3? Group 3 and 4, we all know about group 3 and 4. So group 4th, group second A, where does second A come? First A, second A, it is like group 2 only. This is group 2. And what is second B? So second B starts from second and second B are 11th and 12th. So this is 12th basically, zinc. It's like zinc. Okay. What I'm doing is, sorry, my bad, yeah. Oh, this question is not from modern periodic classification of the elements, guys. This is not a modern periodic classification. This is called as qualitative. This is a qualitative analysis, and these groups are not the Mendeleev's group. These are not the Mendeleev's group. Second A, third A, these are different thing. Okay, so like that you have to think upon. I think aluminium belongs to group 4 because it's hydroxides. Aluminium is an hydroxide, has a PPT. Copper 2 positive and manganese 2 positive. Both of them has sulfide. Sulfide as a, but again we have to rethink about it. Aluminium could go to a 3 also, I guess. Let me check. I think this is right. Aluminium will go to group 3. I'm trying it by my own, not for you people, and this is a qualitative analysis question, and we can skip this question as well. Arsenic also has its sulfide, which is a PPT. Copper and manganese also have the similar one. And what comes right after the hydroxides? First it is chloride, then it is sulfide, then hydroxide, then sulfide, and then I guess comes the carbonates. Anyways, we can skip the question as of now. Let's move to the next question. The characteristics of the 3 elements X, Y, and Z with atomic number respectively 33, 53, and 83 are. So the characteristics of elements X, Y, Z with atomic numbers, this are what? Anyways, we know about these numbers. If it is 33, just simply reduce 18 out of it. So if we remove 18 out of it, it will become 15. Group 15 is your actually non-metal. We are phosphorus right now talking about. And then group 13 will be your nitrogen, phosphorus. Arsenic is arsenic 15 is metalloid. This is not 15, this is 33. This is a metalloid actually. We have 53 with us, guys. 53, which comes as 53. So 53 is I don't know who's 53, but if you remove 32, not 32, because 32 starts from lanthanum. 57, we right after 57 we have to subtract 32. Here we'll remove 18 out of it, and I guess after removing 18 this will become 35, and okay, it will become 35. So this is your 35, and where we get 35? Okay, gallium is actually 31. So 1, 13, 14, 15, 16, 17. 17th group we are talking about. I think this is bromine. and it's a non-metal. Then this is a bromine. Doing 18 will become 17, which is chlorine, and this is a non-metal actually. Bromine, this is the iodine, and it's a non-metal. And the remaining one is 83. So out of 83, you have to subtract 32. So 83 might be anything, but after removing third, actually we know about we know that 86 is actually krypton. No, radon. 86 is actually radon. So before that will be 85, 84, and 83. So this is group 17 halogens. These are oxygen group, and this is nitrogen. So I think this is what we are talking about is polonium. And then comes livermonium. Yes, it is polonium. So polonium is what? I think polonium is a radioactive metal. Okay. So the correct answer should be X is metalloid, Y is non-metal, Z is metal. We are absolutely correct, guys. We had metalloid, non-metal, and metal. Metalloid, non-metal, and metal. Let's have another question. I guess questions are pretty easy. You just need to apply the proper concept and then you will get the answer. Okay, these are not very difficult questions. The correct order of the bond dissociation enthalpy for halogens. So I think fluorine has a lower one because of its small size. More electronic repulsion is there. Cl2 is the highest, followed by bromine, followed by fluorine, and then comes the iodine. So this is the correct order basically followed, and it's a fact based. But I remember I told you this basically, and even if not, then in our coming chapter we call it chemical bonding. We'll discuss the same topic and we'll understand the concept. This is a P block. This also comes in P block in group 17 when we discuss about the halogens. So correct answer should be what? It's a factual question. Cl2, Br2, F2, and I2. B. The atomic number of anilanium 101. Total waste. The atomic number of element anilanium. Oh my god, the same question. Anilanium. N means 9. 109. 109. The electronic configuration of a bivalent europium and trivalent cerium are what? Oh, this is some question, guys. This is some question. So cerium has an atomic number 52. No, yaar, not 52. Lanthanum has 57. This is 58. This is like so xenon 36. We have 6s2 and we have to make it what? Trivalent, 3 positive. So it will be 4, 6s2 will become 6s0 and 4f 5d and 6s is also become 0 and d1 also becomes 0, and I guess this will be 4d1 4f 4f1, right? 58. Now let me think of the another one, which is europium, and europium is 63 with a 2 positive. I remember this comes up as xenon 36 4f7. You remember 4f7? By that time you were talking about 4f7, and so how many electrons are extra, by the way, from there? It is okay, 58 to 5, 63. So 5 will be in this, it will become 5d0 and 6s0. This is the correct electronic configuration. Maybe it's more clarity about writing down the electronic configuration and rote learning everything up will be given in lanthanides, where you will be studying in F block 12th standard itself. But it's better that we have just a look on the answers. Here is the correct answers given. Okay, here I haven't mentioned it, but anyways, correct answer given is D, and we also have got the correct answer as D. So this is from entirely from NCERT. Just have a look, and I also assume it. I don't rote learn them very properly, and let me be very frank over here. Let me be very honest. I also can't rote learn down every single element with its electronic configuration, because specifically talking about D and F block, they have very exceptions of electronic configuration. But I apply somewhere some mind, and I find some concepts are applied somewhere, and you can get out the answer. And as I told you that europium, it's 2 positive, 3 positive, they maintain 4f7 electronic configuration, and even gadolinium 3+. So we also have discussed this part. Next question is symbol for atomic 1119 is Anium. So unanium is correct answer. Unanium, UUE. Lanthanide ion that will show color. What do you think? Which lanthanide ion shows color? What is this question? Lanthanide ion shows color. See, lutetium 3+ has this is the configuration of lutetium. So it doesn't have unpaired electron. There is no unpaired electrons. What I should think, man. I think this should be in D subshell. Some electron might be there. That shows you D transition. Is it so? SM3+ has been given as the answer. Let me check. Samarium. In its 2 state, it has 4F5D0. SM3+ has an electronic configuration of 4F5, and that's why it has unpaired electrons as well. Gadolinium 3+ has 4F7, I remember. Gadolinium 3+ has 4F7. Lu 3+, lutetium 3 positive has 4F14, and La3+ will be having simply fully filled. So I think that was a question. And see guys, what I'm explaining you is this is 57 by the way, and its electronic configuration is also xenon 4F0 5D0 and 6S0. This is unpaired electron in D subshell actually, I guess so. So I think this is 57 to was there, no? 57. I think that's it, and doesn't have no unpaired electron again. So there is no unpaired electron to do the DD transition or FF transition. So that's why these two are colorless. These two are colorless, but what has happened? And this has a configuration of 4F5. It has a 5 unpaired electron which can do the transition, FF transition, and that's because of this color comes. See. Anyways, this is a F block element chapters concept. We'll understand it later. We'll move now to the next question. There's a mixed question have been come up over here. We have a JEE Main 2019 question. The element Z with 120 atomic number will be a what? Alkali earth metal, alkali metal. So 120 is actually what? 118 is actually organozone, group number 18. Then next 119 will come to what? Group number 1, and group number 2 will be 120. So I think this could be alkali earth metal. Aluminum is usually found in positive 3 oxidation state. In contrast to thallium, it exists in positive 1 and 3. And why is it so? Because in thallium, inert pair effect works because of the poor shielding of D subshell. So this is aluminium with electronic with the atomic number is 13, and then we have gallium. Just add 18, it will become 31. Its electronic configuration is neon 3s2 3p1, but the electronic configuration of gallium is argon 4s2 3d10 4p1. So because of this D subshell, we have the poor shielding. This poor shielding makes these electrons inert. I think inert pair effect should be the correct answer. A is correct. Try the next question. Following statement concern elements in the periodic table. Which of the following is true? So all the elements of group 17 are gas. Fluorine, chlorine, bromine, iodine are gas. Iodine is not gas here. Iodine, what do you think? Exists into both, but right after tennessine, and I have no exact idea, but we'll keep things in our mind. Group 13, but for question following statement concern element, which of the following is true, we have to find out. Okay, so I think I'm taking it as false, like considering iodine, and right after that tennessine is a radioactive metal, it's not a gas. So false, I'm taking it. Group 13 elements all are metal. Group 13 is boron is non-metal, so this is false. Group elements of group 16 have lower ionization enthalpy values compared to the group 15 in the corresponding period, which is true because group 15 has P3 configuration, half filled stable configuration, and they have P4 not so stable configuration usually relatively, and group 15 elements. So this is the true answer. No, why are we wasting our time? Let's move forward to the next question. The outer electronic configuration of gadolinium 64 is, I told you that gadolinium always has F7 configuration, and then there will be 3 electron in 4s2 3d1. So let's see, 4f7 5d1 6s2. This is the correct answer. Gadolinium is very important. I told you gadolinium and europium, you must have it in your mind. IUPAC 2006 question came in IUPAC 2006. So guys, right now we are in that time where JEE Main and Advanced didn't used to happen. There used to happen all India engineering entrance exam, and there was a separate exam conducted by IIT. I also appeared in the separate exam conducted by IIT, and I qualified it, and I went to IIT SM Dhanbad, completed my graduation from there in mining department, and now I have come up over here as a chemistry educator. So it's all a loop. I don't know where is anyone going. Coming to 2026, following statements from the periodic table are related to the trends of the chemical reactivity of alkali metals and halogens are given. Which of the following statement is correct in the picture? Number 1, reactivity decreases in the alkali metal but increases in the halogens. This is a false statement actually. Reactivity increases in alkali metal because metals will easily lose their electron to form ionic compounds, and there in non-metal it decreases because size of the anion increases, due to which covalent character arises. And I don't know you remember it or not, but you'll come to know. Okay, not a big problem. Electronegativity is a concept of electronegativity apply there. Electronegativity will decrease of non-metals. Okay, both alkali metal, this is wrong. Chemical reactivity increases and decreases. This is true. C is correct answer. Both no yaar, both nahi yaar. Increases and decreases should come. D is correct. Next question. So according to the modern periodic law, the variation of the properties elements is related to their atomic number. Yaar, this is nothing man. Properties, let it be physical or chemical properties, are a function of the atomic number Z. So the first part of this whole session I have completed, and I took around 1 hour to complete all the questions from periodic properties, trends and all. Now we'll start with some of the we call them periodic properties, and the very one of them is effective nuclear charge. We are right now talking about Z effective. So among them, 2s is orbital is lowest in. Huh? What's that question? So guys, we'll have to think of this question first, because I don't think it's a very weird question. The energy of 2s orbital should be lowest in. So you can do one thing, that if we connect it with the Bohr's model of energy, that energy of the nth orbit is equals to Z is 13.6 Z square by n square. So Z increases, energy increases. You can apply this funda as of now. Rest I don't see any other further explanation. Okay, try it and allow me a second, guys. I'll come back and rejoin you. Until then, you please try to solve some more questions. Okay, you solve it by your own. We have another question. You solve it by your own. This is the question. चलिए शुरू करते हैं guys. So we had this question and I saw one of the text, one of the comment, and somebody is asking me what is diagonal relationship. So diagonal relationship is actually I don't remember it. Like I taught you in the previous session of conceptual explanation, and even if not, let me just give you an idea, a brief idea. All the elements with group second and group 3, elements of group 3 and group 2, which are placed vertically, not vertically, which are placed diagonally to each other, like beryllium with aluminium, lithium with magnesium. They in their compounds have similar type of charge upon radius ratio, or we can say charge per unit volume is quite common, charge per unit area is quite common, and that makes their charge density similar, and their sizes are nearly equal. Their various effects are taken as very similar. Their compounds are quite become similar, like lithium positive, magnesium 2 positive, both nearly show covalency in their compounds, like beryllium 2 plus and aluminium 3 plus also shows covalency in their compound. So this is called as the diagonal relationship. Now relationship as in they show similarities in the properties, but I don't think there's any question related to that. So now I'll take you directly to the question of JEE Main 2019. So one of the question in JEE Main 2019 came from Z effective. Right now we are discussing about that the size of an isoelectronic species is affected by. So see, isoelectronic means electrons are same, so it should be affected by atomic number or number of protons. So which is also called as a nuclear charge, as simple as that. These much number of questions were therein from the segment we just have discussed, Z effective nuclear charge. Now I'll take you to the atomic and ionic radii, one of the very important topic and one of the topic which has been very much asked previously. So there will be like total, I remember 36 38 questions were there just on this concept. Well, I'll take you, but there is a similarity in the question also, similarity in the concept also, and there are like multiplications of the repetitions of the questions you will find. Okay, so don't worry. Take you to the first question. Statement 1 says that the radii of isoelectronic species in the order of this. So basically the radii, this is true because it is directly proportional to the number of electrons and inversely proportional to the number of protons. So if it is number of electrons are the same in isoelectronic species, then higher is the number of proton, lesser is the radii. This kind of concept has to be followed. This is true. The magnitude of electron gain enthalpy is CLFBr, which is also true because this is a factual. I told you the third period elements like chlorine has higher because fluorine is very small in size and belongs to second period and repels the extra electron coming towards it. That's why it is a bit lesser than chlorine, but it will always be higher than bromine and iodine. I think both of them are correct. Next is statement 1. Metallic radius sodium is 1.83 angstrom and ionic radius of sodium plus is lesser than 1.86 angstrom. So I think this is true. Ionic radii will definitely be lesser, right? Because it will be Na plus. One electron is lost. So ions are always smaller in size. No, this is not correct. This is a false statement because if I talk about the oxide ion will be having more radius than normal oxygen, but sodium plus has lesser than Na at ionic radii. The correct answer should be one is true, the another is one false, is true and false, true and false, true and false. So I think this is correct. D. Next is the statement that is correct about these isoelectronic species. Isoelectronic species, they all have same number of electron. True. They all have same nuclear charge. No, false. The O2 is the largest, which is true. Mg2 is smallest, which is true. The only incorrect is B. The most appropriate answer. Okay. I think A, C, D. A, C, D. A, C, D. B. Woohoo! Next is another question came in JEE Main 2014. 2014 here, this is 2024. So we have a question says that this is group period left to right group So what is true about ABCD? So order of atomic radii, usually atomic radius increases down the group and decreases left to the right. So it should be C might be having more than D, and then I think this is correct. A is correct. Metallic radii, we have metallic character. C and D will have more metallic character than A and B. So B has less than A, correct. I think this is also true, but not typically I can comment about anything. Size of the element should be size of the element and order of atomic radii is the same, and A cannot have the, this is a false statement. This is false statement, or we can say this is incorrect. Then order of ionic radius, C positive, B positive, A1 positive, A should be bigger in size than, no, one extra electron is there. So let us suppose if I consider them, so positive, I think it is also correct. 3 is the answer, I guess. Huh? What do you think? No idea on answer, but yes, this is also true. Okay, you can try all these questions, you can download all the notes, and then you can let's have another question. The correct increasing order of, अरे आवाज कैसी है यार? Correct increasing order of the ionic radii. So chloride will have the highest, sulfide will have the highest, then chloride, then K positive, then Ce2 positive. This is the correct. Apply the concept of isoelectronic species, guys. For all isoelectronic species, their radius is directly proportional to the number of protons or Z. Another question, in Cl2 molecule, the covalent radius is double of the atomic radius of chlorine, which is true. Covalent radius is double of the atomic radius of chlorine. This is false, man. These two are same actually. This is false. The radius of an ionic species is always greater than the parent. This is true. So one is false, another one is true. See, statement 1 is incorrect, 2 is correct. Next, the ionic radii of oxide and magnesium 2 positive are the same. So let's see if we can have that. The ionic radii of oxide O2 minus and Mg2 positive are the same. Ionic radii, which is absolutely nonsense thing to talk about. It's a false statement. We know that the radius of magnesium, we have radius of oxide greater than that of magnesium, because higher is the Z effective, like that. Okay, then this is false, and both are isoelectronic, which is true. So the correct answer should be A is false, B is true. A is false, B is true. Option D. The correct order of increasing radii, I think this is something which we have done it very repeatedly. This kind of concept in isoelectronic species directly proportional to the 1 by Z. So Z is higher, lesser is the atomic or ionic radii. I guess the correct answer should be nitride has the highest size, followed by oxide, fluoride, sodium, and then magnesium. This is correct actually. Then in 2021 this question came, exactly the similar question. Phosphide will have the highest, and I think this is correct here. This is very simple questions have been asked here. It's the same question, same concept has been used, that radius is directly proportional to the 1 by P, 1 by Z. 1 by Z is Z actually your atomic number, and higher is the atomic number, higher is the Z effective, and smaller will be the size. And electrons are the same, so they will experience same sigma. Then barium carbonate is insoluble in water and highly stable, which is true. And the thermal stability of carbonate increases with increasing cationic size, which is also true. So I think it's true and it's correct explanation as well. Same question, another same question. Sodium will have the highest. No. This is in the order of potassium. No doubt will have the highest because it belongs to third period. All of them will go to the second then, and then Na plus, Mg2 plus, and then comes Al3 plus. Where can you find this order? C. Look at the next question, guys. So we have Na positive here. The size of these will be Na positive will have the highest, followed by magnesium, followed by aluminum, because same number of electron is there, and radius will be inversely proportional to the atomic number Z. So the correct order should be what? Both of them should be lesser, and magnesium should have higher than aluminum. So I think B is correct. Try the next question. Yaar, no need to try. Yaar. You just have seen this question earlier. O2 minus, N3 minus with highest size, Al3 plus with the lowest size. This is correct. Oh no. This is incorrect order. This is correct. Okay, yaar, exactly the same question, yaar. Why the same questions have been asked, yaar? Aren't you guys like surprised? I'm not so happy with the repetition of the questions. Flow, oxide, fluoride, and same 2020 with this question has come. Fluoride, oxide, magnesium. Oxide will have the highest. This is the correct order. No, yaar. This is incorrect. These all are isoelectronic. Okay, next. Now this is some different question. Increasing order out of these all. So this is carbon, oxygen, carbon, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So what do you think? Bromine should be the highest size. Radius will follow the order of. Bromine is the highest. Then chlorine. Then I think comes the oxygen, carbon. No, then comes the carbon, oxygen, carbon, nitrogen, oxygen. Simple. This is the order of radius. How did I decide it? I followed the same, that left to right R decreases, down the group R increases. That's what I followed simply. So I think the correct answer should be E D. This is incorrect. E D A B C. This is correct. B. Absolutely correct, guys. Next is the correct order of the atomic radii of these all. Similar question here, and even the similar concept as well. We'll go fastly and finish it ASAP. Cesium is the highest atomic radii, undoubtedly, though there is no comparison with cesium. Then comes the aluminium. This is carbon, sulfur, aluminium, cesium. That is the order I follow. Oh, similar question, similar answer. I'll simply pick the correct answer. Nitride, oxide, and fluoride. Nitride has highest, then oxide, and then fluoride. So nitride highest. This is the correct answer. Increasing order of isoelectronic species. I'm bored of this, man. Increasing order of ionic radii. Sulfide will have the highest, then chloride, then potassium plus. Increasing order. This is correct. Yeah, I'm tired of these silly questions. Very easy. Next is correct sequence. Again, same question. IEEE 2010. Similar questions have been asked, man. It's frustrating, yaar. D is the correct answer, yaar. Seems like we'll finish all these questions in just 1 hour then. If these are very easy and they are very much, they're repeated, yaar. Set of correct order of ionic radii. Dekho, lithium plus have lesser than sodium plus. Sodium plus has more than magnesium plus. Beryllium has more than this. So actually, most of that will be Na positive. Na positive will have the set of correct ionic radii. And this is the only answer, yaar. Which one of the following ion has the highest value of ionic radius? I think these all are, no doubt they are not isoelectronic, but still oxide has the highest potential. The reduction in the atomic size with increasing atomic number is a characteristic element of reduction in atomic size. Reduction in atomic size with increase in atomic number. So if we go, okay, F block, right? If we go from left to the right, I think the size decrease. How come? Reduction in atomic size with increase in atomic number is characteristic of elements of D block. Also it decreases. In D block it decreases, then constant, and then increases, something like that. So I think it's increases the reduction in atomic size with increase in. It's, I don't know when यहाँ पर भी देखने को मिलेगा. This is also true. This is also true. We call it lanthanide contraction. In radioactive series also it is true. And I think, but higher atomic masses is given to us. I think D is correct. I think all of them have the higher atomic masses only. All three have the higher atomic mass. It's a question of confusion, by the way. Actually, I didn't get its language properly, and I don't know how come the answer is given as 4, because all of them were correct, I guess so. Like if we move from left to the right in increasing atomic number, atomic radius decreases. We have heard of it. We have learned of it. Even lanthanide contraction is the same thing. D block also says the same thing, trend of the same thing. Anyways, let's see another question. We have plenty number of ionic radii of these all. So this is like one of the very easy question which has been directly picked up from the this is C, lanthanum 3+, and it keeps on decreasing. So 1, 2, 3, 4, 5, 6. So if I write down their name, Separ and Pumsum, you God तब दिए हो, you God तब दिए हो यार तुम ये भी लो. Now you can check. La plus is the most in size, then cerium, then PM, and then YB. I think B is correct. This is called as lanthanide contraction. This is basically the radius, and this is the atomic number Z. Next, correct order of ionic. Again the same question, and we all know that it decreases. So Separ and Pumsum you got tab diye ho yaar tu ye bhi lo. A is the correct answer. That's how we ended it. We have another important property, and this is another same property, one of the periodic properties. This is ionization enthalpy, but believe me, ionization enthalpy has vast number of questions in it, and I guess this is the major topic with us. Right after this we can have a small lunch break also, so probably we'll expect, let's say, half an hour we are investing into this topic, because I remember 35 to 40 questions were there. Just like radii we had plenty number of questions. Ionization enthalpy we have plenty number of questions from 2002 to 2025. In fact, in 25 a question came. Let me show you that question. Here is the question, came in 2025, and believe me, this question was a different question. It was a questionable question. Questionable question as in like it was a challenged question. The answer in the NCERT, not NCERT man, the answer given by NTA was 4 and 1. This was given by NTA. but the correct answer is 4 and 3, which was a corrected answer. Now you might be seeing what is the meaning of this. B is the correct answer, but how? Let me show you. We have plenty number of elements over there, and we have to find out the most stable oxidation state of the elements with highest and first and lowest ionization energy. Highest will be what? So if I talk about all of them, where can you get the highest? It will be definitely for the, see, we in the left hand side we have we have 13th and 14th elements. 13th group element generally have lower oxidation, lower ionization energy than the 14th one. So definitely the one with the highest will be of 14th. And out of tin, germanium, lead, we have it is silicon, germanium, tin, lead. Wait. First ionization enthalpy highest will be of carbon, silicon, germanium, tin, lead. So carbon is not there, silicon is not, germanium. So germanium is the correct answer. So germanium has the highest IE1 out of all of them, and lowest will be of indium. I remember, because in indium, first of all 13 if you talk about indium as the at the lowest out of all three. So this has the lowest ionization energy 1. Now if you compare both of these elements, germanium and indium, its most stable oxidation state will be germanium 4 plus, highest oxidation state, and lowest first ionization enthalpy. No, yaar, it's the stable oxidation states are 4 plus and 3 plus. So iron 3 plus and germanium 4 plus. These are the correct answer, B. There we go with the next question. Same concept, ionization enthalpy has been used. The first ionization enthalpy values for first 4 group 15 element are given below. Choose the correct value for the element that is a main component of apatite family. Is he talking about phosphorus or what? So first ionization enthalpy of first 4 group elements are given below. Where are they? These. The correct value of the element that is a component of apatite family. I don't know what is this question about. I think it is asking us for the first ionization values of these are given. Okay, first ionization enthalpy's values are given like this. So we have to identify the one which is having the apatite family. No idea. So what elements are there, by the way? We have nitrogen, phosphorus, arsenic, antimony, bismuth. If I arrange them in their, we all know that their ionization enthalpy 1 simply decreases on moving down the group. So nitrogen will be having highest 1402. This is 1012. So this is 947 and this is 343. This was asked which one is them will be having for apatite family. This is P. P is the correct answer. Will be D. See? It's a simple question, by the way. Okay, D is correct answer. You're right. Rajaji, Ranjit, you're right. Another question. The correct order of first ionization enthalpy values of lithium, sodium, fluorine and chlorine is this. Sodium is lowest, fluorine is the highest ionization enthalpy. I guess this is true. The correct order of electron negative affinity values. Okay, electron affinity. Chlorine will be having highest, fluorine. I think this is also true. Both of the statement are correct. See? Next, correct order of ionization enthalpy. So we don't need to be worried of anything, guys. This is a JEE Main 2024 question. I told you one WWE graph there. This goes between these two. This is the highest one. So this is boron. This is aluminium, gallium. See, indium is the lowest one out of them, and then becomes the thallium. And this is, what is it? What is this of? This is first ionization enthalpy graph with Z. So the correct answer should be what? Gallium has the highest out of these all, and then aluminium, and then come. No. Boron, gallium, aluminium. Boron, gallium, aluminium. Boron, gallium, aluminium. D is the correct answer. अरे यार क्या हो रहा है ये? Oh. Next is another question. The correct order of first ionization enthalpy of oxygen, nitrogen, beryllium, fluorine, boron. So I told you once that, let me just rewrite them. Like this is beryllium, boron, carbon, nitrogen, oxygen, fluorine. So these are the number of elements that have been given to us. Yeah. So fluorine will be having the highest probably. This is 2p5, p4, p3, p2s2, 2s2, and this is 2p1, 2s2. So the correct answer should be, this will jump from here, this will jump from here. The correct answer should be fluorine, nitrogen, oxygen, boron, beryllium, and then comes boron. So now what boron is there? Boron, where are you? Boron, anyways, this is E, beryllium is C, oxygen is A, nitrogen is B, and fluorine is D. So DBACE, DBACE, DBACE. Oh man, DBACE, DBACE. This is correct. C. Next question. Try it by your own, guys. Try it by your own. Melting point order, ionic radius order, L3 plus, and so many things have been given to us. Anyways, the ionic radius is pretty simple, and it keeps on increasing down the group. Thallium, indium, but only gallium doesn't have more than aluminium. So this is the ionic radius. And the only option is D actually here. So A, metallic radius, melting point. Melting point is highest for boron. And first delta H1 I, ionization enthalpy, order of ionization enthalpy will be, boron is the highest, then comes thallium, and if you remember that, no? Boron, aluminium, in, so this is the correct order. Boron followed by thallium, followed by aluminium, followed by gallium. No idea, dude. Radius is pretty simple. Radius is actually, atomic radius is this. It's not the ionic radius, this is the atomic radius. Boron has the highest atomic radius. No, yaar. Man, what's my doing, yaar? Thallium is the highest one, then indium, then aluminium, then gallium, and then boron. This is correct. Then first ionization enthalpy is nowhere is it is correctly mentioned. A is given as the correct answer. A is the fourth. A is the fourth. Melting point can be this. What is it? Fourth. D is 3. B. Ionic radii is 1. The ionic, it will be simple increase. Okay. Nice. This is good. And this will be B. Ionization will be. Okay, allow me a sec, guys. Some noise is ongoing, guys. Try the next question. Element with highest first ionization enthalpy. carbon. So we have this arrangement: carbon, silicon, and then we have nitrogen. Then we have aluminium. So ionization enthalpy left to right increases, and down the group decreases. So I think nitrogen is correct because of its stable P3 configuration. Let's try the another question. So guys, some constructional work is ongoing, which is that's why I would like to take a break from here, and we'll announce a small break. So guys, some constructional work is ongoing, which is that's why I would like to take a break. We'll announce a small break. So guys, some constructional work is ongoing, which is that's why I would like to take So guys, seems like now this issue has been resolved. We were receiving too much of noises from the outside. Some construction work was going on, but anyways, it has kept down now. So we'll restart our session from the wherever we left the session with. So this is the question we left with: the first ionization enthalpy highest for the most stable electronic configuration for nitrogen. Then we'll have the another question over here. Okay. So let's see, we have the next question here, everyone with us. Question simply says that these questions all are based upon ionization energy, and this topic is very much important, have been asked previously various times. Question simply says that there are assertion reason question. Assertion is the first ionization enthalpy decreases across the period, which is false, because if we go left to the right, the first ionization enthalpy increases because Z effective increases. The increasing nuclear charge overweights the shielding across the period, which is true. But so reason is true, but assertion is false. What is this? A is right. Won't take another half an hour or like 1 hour. More than that we won't take. We'll simply finish this whole remaining part of this chapter, and quickly we'll do it, okay? Because the construction may start anytime, so we'll try to quickly wind up all the session, wrap up everything. The transition metal having 3D, third ionization enthalpy is highest. So guys, let us first take all together: Mn3 plus, 3 plus, Cr 3 plus, and we also have vanadium 3 plus. So whenever highest energy has been asked and n positive number of oxidation states has been given to you, that means you have to first of all look at the electronic configuration. So I guess electronic configuration of manganese 3 plus will be argon 3D. This is actually 25, 26, 24 and 20 scandium platinum vanadium 3. So this is argon, and 4s2, so 4s0 and 3d4. This is argon 3d5, 4s0. This is argon 3d3, 4s0. This is vanadium, scandium, titanium, vanadium. So argon 4s0, 3d3, 3d2. So where can you find the most stable configuration? Highest third ionization enthalpy. Oh my god, I think we have to take 2 plus in the account rather than taking 3 plus. Third ionization we are talking now, we have to consider 2 positive, because if we consider 2 positive, then the most stable one will not go further for ionization. So we can take 2 positive, 2 positive. I just increase one electron each in D. This will become what? 3D 5, 4s0, 3d5, 3d6, 3d4, and this has become 3d3. Now I think manganese has the most stable configuration, right? So removing one more electron from manganese will be very difficult. This is already stable. Already it is half filled and it is already stable. So this will be like manganese is the correct answer. Look at this. The same explanation can be given in terms of electronic configuration. But you always have to check whenever these multiple oxidation state have been given, like oxidation state is 2 positive, 3 positive, then using electronic configuration you can get to the idea. Otherwise, if 1 or 2 positive has been given, or then in that way we have to actually check upon their theoretical value only. Like IE1 for the metal always has a this order of first it is increasing, sorry, it is decreasing, no, it is increasing, nearly same, and something is there, but it's inappropriate. We should say the regularity is not in the order, and that's why IEN values are difficult to post upon, but multiple various one can be explained using the electronic configuration. Let's move forward here. Next question is, the energy required to Mg2 positive to form Mg is much higher than required for Mg positive, which is true, because there we require 2 electron to remove. Initially we required only 1 electron to remove from Mg plus. So Mg2 plus is small and carry more charge than Mg plus, which is also true. So both of them are true, and it's not a correct explanation actually. Okay, it is the correct explanation as well. How? So the energy required Mg2 plus from Mg is much higher than required to produce Mg positive. Okay, to produce Mg positive. Okay, yes. Because guys, when you provide it IE1, it becomes Mg positive, and then providing IE2 by leaving electron, it becomes Mg2 positive. The magnitude of IE2 is way more than a magnitude of IE1, and that is the explanation is all about. So I think this is the correct explanation. Next question. We all know about second period series. It was asked in JEE Main 2023. We know 2p series, second period. We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So writing their electronic configuration: 2s1, 2s2, 2s2, 2p1, 2p2, p3, p4, p5. Which one of them has the most stable configurations? Wherever it has the most stable configuration, there it will jump by 1. Right, not like that. It will jump to this position higher, because left to right increases, no? Beryllium will have the higher than boron. So let us write the exact correct order. The most will be for fluorine, then nitrogen, then oxygen, then carbon, then beryllium, then boron, and then lithium. This is the order: fluorine, nitrogen. So fluorine, nitrogen, oxygen, carbon, beryllium. I think this is the correct answer. D. D is correct answer. So there we have it. D is the correct answer. We will move to the next question asked in JEE Main 2023. The decrease in the first ionization enthalpy from boron to aluminium is much higher than that of aluminium to gallium, and I think this is right, because d orbitals in gallium are completely filled, and because of that they have poor shading, higher Z effective, making change is quite like, in fact I remember aluminum has a higher ionization enthalpy, sorry, gallium has high ionization enthalpy than aluminium. Correct answer are both of them are correct, but none of them is the correct explanation, because this is assertion reason, not assertion reason question. It's just statement based question. Next is, but that was a correct statement also, correct explanation also. Assertion reason here is the first ionization enthalpy of 3D series is more than that of group 2 metal, so which is true. Whenever we move to the left to the right, the ionization enthalpy increases. Okay, 3D series we are talking about. So scandium, titanium, vanadium, they all will be having higher than the potassium and calcium. In 3D series, the element successively filling with d orbital takes place, which is also true. So what you should think? I think A is false and R is true. First ionization enthalpy of 3D series is more than that of group 2 metals. What are group 2 metals? Yeah. The group 2 metals are, this is beryllium, magnesium, calcium, and who are 3D series members, they are written like this: scandium, from there they start scandium, titanium, vanadium, chromium, manganese, cobalt, nickel, copper, zinc. Okay, but you will see that ionization enthalpy 1 for beryllium is higher than the ionization enthalpy 1 for the 3D series member. So it might be higher for they might be having higher ionization enthalpy than calcium, strontium, barium, but not than magnesium and beryllium, and that makes this statement false. But second is correct, that in 3D series successively one electron is filling in the d orbital. So scandium, titanium, this is as 3d1, 3d2, 3d3, d4, d5, like that. So that was the question all about. The correct answer should be A is false, B is correct. Next question please. Sodium, magnesium, silicon respectively, they have electron ionization enthalpy is like this. Then aluminium must have what? So we have C, sodium, magnesium, aluminium, silicon. Let us write the electronic configuration. This is 3s1, 3s2, 3s2, 3p1, and this is 3p2. So we know that this is a stable configuration. This will come, this is the third period basically we are talking about, 3p, third period actually. So in third period, this is the correct order of ionization enthalpy. So silicon, magnesium, aluminium, and then comes sodium. This is the order of IE1. So you know the value of magnesium here. How much is the IE1 for magnesium? 737. That for sodium is how much? Sodium 496. So this should come intermediate of these two, 496 to 737. 487 no, 768 no, 577 right. C is correct answer. That's how you have to make the sense out of this question. Correct? C. We have next question everyone. The incorrect statement. This question was asked in JEE Main 2022. The incorrect statement about this is the first ionization enthalpy of potassium is less than that of sodium and lithium, which is true, because as we move down the graph, the size increases and ionization enthalpy decreases. Second is xenon does not have the lowest first ionization enthalpy in its group. Xenon does not have lowest first ionization enthalpy because helium does. So that's why this is a true statement. First ionization enthalpy of element with atomic number 37. I think 37 is potassium plus rubidium and strontium. The first ionization enthalpy of element with 37 is lower than that of atomic this. This is true because left to the right, if we move left to the right, the ionization enthalpy 1 increases. And at last, the first ionization enthalpy of gallium is higher than the D block elements with atomic number 30. We all had correct. I think this is the only false statement. Correct, because the first ionization enthalpy of gallium is higher than that of the D block elements with atomic number 30. So we are right now talking about zinc. So zinc has more ionization enthalpy 1 than gallium, because this has a fully filled 3d10 configuration and this has a 3d10 4s1 configuration. No, 4p1. 4p1. So this is very difficult to remove an electron from zinc than gallium. So this is the correct answer, guys. This is actually a false statement and this was asked in the question. The false statement, D is correct. Let's have the another question. The first ionization enthalpies of beryllium, boron, nitrogen and oxygen are following the order of what? So these all are the second period element. We have beryllium, boron, carbon, nitrogen, oxygen, but we know that nitrogen will be shifted from here because it has 2p3 configuration, and this has 2s2 configuration will be shifted from here. Correct order will be oxygen. No, nitrogen is the highest, oxygen, then beryllium, and then least one will be with boron. This is the order of first ionization enthalpy. Now check out the correct answer, guys. BBEON, BBEON, BBEON. This is D is the correct answer. So Aman is asking me, sir, I have a coaching at 3 p.m. So when will be getting free? Oh, anyone wants to answer that? But so Aman, it's a suggestion that it's a free lecture you are right now attending. You can find the same lecture on the same channel, and that stream will be actually recorded by that time. So you can watch this lecture again once you get free from your coaching time. But yeah, it will take us another 1 hour to finish the remaining part of this chapter, which is electronegativity, electron gain enthalpy, nature of the oxides. These three are the major parts which right now are remaining right after ionization enthalpy, because ionization enthalpy is the primary and most important part of this particular chapter. Let's have the another question from here, appeared in JEE Main 2022. What the question says, it's an assertion, reason based question. Assertion is the first ionization enthalpy for oxygen is lower than that of nitrogen, which is true because nitrogen has a configuration of 2p3, the more stable configuration relatively with the oxygen. The 4 electrons in 2p, oxygen experience more electron repulsion, which is not a correct reason. Sigma might be more in oxygen, so does the Z effective, and that's why I think A is correct. B is also correct, but it's not an explanation behind the more ionization enthalpy of nitrogen, because we have nitrogen with 2p3, oxygen with 2p4, and higher ionization enthalpy is with the because of its stable configuration, not because of the higher electronic repulsion is there in oxygen. But electronic repulsion is actually helping us to have the lesser amount of this energy. But yes, oxygen is not the one, or electrons are not the one which are helping in this matter. Both of them are correct, but not the explanation. The correct order of first ionization enthalpy out of these all belongs to the third period. They all members are sodium, magnesium, silicon, phosphorus, aluminium, then we have sulfur. But anyways, these what we have to talk about: magnesium, aluminium, phosphorus, sulfur. Phosphorus has 3p3. Phosphorus has a configuration of 3p3, shifted from there to here. Magnesium is also shifted from aluminium. The correct order should be phosphorus followed by sulfur followed by aluminium, nahi, followed by magnesium and then aluminium. Can you find the correct order, guys? ALMGSP, ALMGSP, ALMGSP. C is the correct answer. So let's not waste the time, move forward. Okay, thank you, by the way. We have another question, guys. The first ionization enthalpy of magnesium is smaller compared to the X and Y, but higher than that of Z. So what could be these elements? So anyways, we have been given up with a set of elements over here, and we have to compare what X, Y and Z are. We have magnesium first of all, which has an electronic configuration of 3s2, which is a stable configuration relatively. So a one which is having smaller ionization enthalpy than this, smaller compared to X and Y. Okay, so X and Y are higher. I remember neon and argon, both of them are higher than this, and even chlorine is higher than this. So I think this is correct answer. B is correct answer, because guys, argon and chlorine, it has they both have higher ionization enthalpy, IE1, than magnesium, but sodium has lower ionization enthalpy than magnesium, because it's very easy to remove the one electron from sodium. Correct answer should be B, but we didn't check for the other options, and I don't think it was required because we were very much sure about the B option, and we'll move forward. So these kind of questions have appeared in previously some years, and you might have seen these questions are not very difficult. These are even picked from the NCERT, or if you have studied very well your NCERT, or you might have attended all of our lectures which we have provided till now, you could have scored very well in the JEE examinations. I have come up with 2002 to 2025. A lot of questions are here, around 175 questions I picked it. Not actually 175 is too much, but yeah, around 150 questions are there. But 150 questions which we are right now doing, I have solved around half of them. We already have solved 75 questions out of them, and right now we are in the ionization enthalpy. We will also have some of the more important topics such as electron affinity, electronegativity, nature of oxide. There also will come up with the rest and remaining 70 or like 60 questions. So let's move forward and be very energetic guys, just like your chemistry educator Sanjay sir. Identify X and Y using the ionization enthalpy like this. Now how we should do it? Okay, X and Y. So what do we see? That first ionization enthalpy is this, second is this. First is this, second is this. Definitely X has a valency of 1, because right after removing one electron it has become a noble gas configuration. So definitely X is this. I think C is correct answer. C is correct. यार very easy questions are there यार, seriously यार, very easy questions यार. I'll take you to the next question here. There are two lists, list 1, list 2. List 1 says that there are some electronic configuration, list 2 says that there is some enthalpy of ionization. So we have to compare the enthalpies of ionization. So wherever there is a most stable configuration, which we can see, this P3 will be having the highest highest ionization enthalpy. So this belongs to the fourth. And then right after this, whatever the okay, like that we have to do. Then we have 1s2, 2s2, a stable configuration, another relatively stable configuration. Okay, so let's check B and D. B and D, if we talk about B and D, we will have D will be B will be having more than D. So B, and normally they will have like that. So this will be A. This is how it is gonna to be. Okay, D belongs to 1, and C belongs to 4, and B belongs to 1. B belongs to 1. B belongs to 3 actually. No, yeah. Let me write them what these elements are. 1s2, 2s2. It is 2s2 or 2s3. 1s2, 2s2. Hydrogen, helium. This is beryllium. This is boron. And this is nitrogen. And this is oxygen. I think now we have everything with us. I can do it now accordingly. So we have beryllium. The order will be boron. Beryllium will be having more than boron. Then we have oxygen, and then comes the nitrogen. Now you arrange them: 1402, 1314, 899, and 801. So how are these gonna to match up with? This is boron is actually D. Beryllium is A, oxygen is B, and nitrogen is C. So A, B, C, D are there. Now you arrange them and you will get your answer, man. D belongs to 801. A belongs to 899. 1314. This B belongs to 1314. B belongs to C, third year, and nitrogen belongs to the final one. So can you see the correct answer as 2341. 2341. So we have 2341. I think C is correct. Questions are not difficult. The questions are absolutely not difficult, but a correct way has to be applied. In order to solve these questions, we have to apply the correct approach to get the answer out of it. See, absolutely correct. We have another question of JEE Main 2021. Magnesium, aluminum, sulfur, phosphorus, and silicon are there. Increasing order of their first ionization enthalpy. So first of all, let us write them all together in increasing order of their atomic number. We have third period. This is third period member, and we have magnesium, then have aluminum, then have sulfur, then have not have sulfur. We have then silicon, phosphorus, and sulfur. So actually, how we do it? We have this is 2p3. So this is come next to it, and this is actually 3s2 will come next to it. So the correct order should be phosphorus have the highest, sulfur, silicon, then have magnesium, and then have aluminum. So this is the correct order, guys. Can you find it? PSSIMGAL, PSSIALMG. Like no. This no this PSISMGAL B. Oh, PSSIMGAL सही तो है. PS. Oh, sorry. This is correct. What I have made is correct, but just try to be even more focused when you pick the options, okay? Otherwise, you will suffer the one which I have just. Well, we have next question. There are 5 successive ionization enthalpies, 800, 240, this. But from here to here, we saw abrupt increase in ionization enthalpy. So there is an abrupt increase. That means here, after third electron is released, it has acquired stable configuration. If it has acquired stable configuration, the valence electron should be what? 3. 3 electrons are removed, and then fourth requires 25024. Very much amount of energy. This is called as, like, the valency is 3 over here. It could be an aluminum, it could be boron. Among these statement 1 to 4, the correct ones are: number 1, beryllium has small atomic radius than comparing to the magnesium. They have nearly similar radii, but yeah, beryllium has bit smaller than that, I think so. So let's say this is true. Then beryllium has higher ionization enthalpy than aluminium. Beryllium has higher ionization, which is absolutely true. The charge upon radius ratio of beryllium is greater than that of aluminium. See, charge of beryllium is 2 plus, right? For beryllium it will be what? Beryllium 2 plus, and for aluminium will be what? Al3 plus. So I think aluminium will win. So this is a false statement, because this charge by ratio is more dependent upon the charge in the radius, okay? And both beryllium and aluminium form mainly covalent compound. So this is also true because of their high electron density. High, guys, this is like some of the concept has been taken from covalent chemical bonding. Some of the concept has been taken from chemical bonding. Chemical bonding, we study about a simple thing is there. We call it what we call it? Fazan rule. Fazan rule is there, which explains the covalent character present in the ionic bonds, and that's why this is like high polarizing power. High polarizing power makes it. I think D should be the correct answer. What do you think? First, second, and fourth is correct answer. So first, second, fourth, where is first? Okay, first, second, fourth is correct. We have also written the same. First, second, and fourth is correct. A is the correct answer. Okay, the answer is already given over here. The first and second enthalpies are these. How many moles of HCl? So this is there is a huge gap between first and second. That means it's a first group element. Let's say the element is sodium, reacts with HCl to give you what? NaCl plus half of H2, and if it reacts with 2Na plus H2SO4 gives you what? Na2SO4 plus 1 H2 molecule. So what is the molar ratio between the 1:2? So 1 and 0.5 is the correct answer. See. So respectively needed to react completely with 1 mole of metal hydroxide. Oh man, oh man. This is a different reaction it is talking about. But anyways, the correct answer is this. This is asking that if it is NaOH and we have to take it 1 mole, then how many moles of HCl will be taken? This will be taken as 1 mole. Acid-base reaction will take place. NaCl will be the salt formed and along with water. If we carry out the same reaction with NaOH, 1 mole is there, and H2SO4, it will be required with 0.5 mole. Why we are taking 0.5 mole of this? Because it will give you 2H plus 1H. It will give you 1H plus half Na2SO4. So correct answer is 1 and 0.5. Please check out the answers carefully and try to solve the question by your own. Make sure that you attempt it very well by your own end. You face any kind of doubt, do let me know in the comment section. Some of you students have posted the doubts already. I saw Aman has some doubt. Ranjit initially posted a doubt. Ranjit, we had one more student. अरे यार उसका नाम क्या था यार? So like that, okay. Anyways, we'll move forward to the another question. Boron has a smaller first ionization enthalpy than beryllium, of course, because beryllium has a stable configuration. Because it is easy to remove 2p electron than 2s electron. But 2p and 2s electrons are the equal number of electron over there, na? 2p electron of boron is more shielded from the nucleus by the inner core of the 2s electron has more penetration power than 2p. Atomic radius of B is then more than this. Considering following statement, it is easier to remove 2p electron than 2s electron, which is true because 2s electrons are quite closer to the nucleus. Being spherical in shape, they are closer to the nucleus. 2p electron of B, boron, is more shielded from the nucleus by the inner core of 2s electrons, that of beryllium. Typically, this is also true. 2s electron has more penetration power than 2p electron. What is this penetration power? I guess it's an attraction towards the nucleus. This is also true, I guess. And but we haven't seen, we don't know any of the option which has 1, 2 and 3. Okay, atomic radius of boron is more than that of beryllium. We moved later on. This is false statement. I think 1, 2 and 3 is the correct answer. So 1, 2 and 3 is the D option. Absolutely, guys. Congratulations. Congratulations. Let's see another question from JEE Main 2020. The first ionization enthalpy of sodium magnesium aluminum. I'm tired of doing the similar questions again and again. Yeah, this is very easy questions. Yeah, you do it by your own, man. Sodium, magnesium, aluminium, silicon. If you talk about the ionization enthalpy, this will become, this is 3s2 and this is 3s2 3p1. This will shift the position. This is the order. This is the IE1. Now you can put the correct values and you can find out it. Third ionization enthalpy is minimum 4. Third ionization enthalpy is minimum 4. So if you want to find out which one of them will be having third ionization enthalpy as minimum, we have to check it for a minimum. That means we have to make it a doubly positive ion. Doubly positive ion, we can check which one can easily release the electron. That will be having the lowest ionization enthalpy. Third. So let's start it from the nickel 2 positive. We have Ni 2 positive. Configuration is argon 4s2. So 4s0 and 3d 8. Talking about cobalt 2 positive. Cobalt 2 positive. Argon 4s0 3d7. Manganese will be 3d5. I think manganese is the correct answer. No. It is asking for the minimum. Oh, I think iron is the correct answer in that way. This is argon. This is 4s0 and 3d5. This will require an electron. So IE1 is the highest among all of them because this is a stable half-filled configuration. But now coming to the iron in 2 positive state has an electronic configuration of argon 4s0 and 3d6. We can easily remove one more electron. So we can remove an electron and this is your IE1 and not IE1 here. I must write it IE3. I think iron is correct. See, electronic configuration helps in several ways. Next, a comparison to boron and beryllium. Boron, okay, if we talk about boron, beryllium has what? Does beryllium has lesser nuclear charge and greater first ionization enthalpy? Beryllium has greater ionization enthalpy and lesser nuclear charge is an incorrect term, by the way, but might be. I think it's right. First ionization enthalpy, it's right. I told you, no, it's right. Actually, first ionization enthalpy of beryllium is more than that of boron because of its stable configuration of 2s2. But again, Z effective keeps on increasing, moving down left to the right. So Z effective increases. So the correct answer should be A. Beryllium has lesser Z effective than boron and boron has lesser ionization enthalpy than beryllium. Next question, please. The element having greatest difference between the first and second ionization enthalpy will be what? Okay, it is here first and second ionization enthalpy. Man, first and second ionization enthalpy means if it is first ionization enthalpy is done, that means it is valency will be 1. And right after losing one electron, it becomes stable noble gas configuration. So I think potassium is the correct answer without any doubt. Check it out without any doubt. So that's how we do it as quick as possible. Sir, next chapter कौन सा होगा? Possibly take P block. Okay, we'll see. By the way, right now I'm planning for chemical bonding because chemical bonding has those kind of concept which will be required in our block chemistry of SPDNF. So I think first we need to finish chemical bonding, then will I take you, and definitely I'll take you to P block, no problem. We'll continue our inorganic chemistry then. Okay, the electronic configuration with the highest ionization enthalpy. Okay, we can check it out, guys. This is P3, this is the correct answer, and we go down the group, ionization enthalpy decreases, so definitely D will be having lesser than C. C is the correct answer. How easy, man, how easy. Which of the following is correct? A and B belong to group 1, group 3. Okay, I'll do it. See, this is the sudden jump, this is the abrupt jump. Delta E is huge. That means it has a valency of, A has a valency of 2. A has a valency 2. Now if we talk about 737, 1450 and okay. Both can belong to, but okay, this again here also delta E is very huge. That's why this is also the valency overall is 2. So this is like these are like belonging to the same group. B might be at lower position, so this could be potassium and this could be magnesium. Now please check out the correct answer. Both A, B belong to group 1. No, they all belong to group 2. B comes below A. B comes below A. I think this is correct. C is correct answer. C is the absolutely correct answer. That's how we do it. Now let us check about the correct order of the ionization enthalpy out of these: calcium, barium, sulfur, selenium, argon. First of all, let us put them in the correct way. So we have third period elements here. This is calcium, this is barium, this is sulfur, this is selenium, and this is argon. So no doubt argon has the highest one comparing to all of them. Argon followed by selenium, followed by sulfur, argon, sulfur, then calcium, then selenium, and then sulfur. No, this is wrong. Argon, sulfur, yaar, this noise, yaar, I'm tired of it, man. सुन रहे हो? ये आवाज नहीं आ रही क्या तुम्हें? अरे नहीं भाई, थोड़ी देर पहले नहीं थी इसलिए नहीं आ रही थी. पक्का? हाँ बहुत, एक होता नॉर्मल आवाज, एक होता भयानक आवाज. आप जब ये लाइव जाके देखो, ये मोबाइल में तो क्या नॉइस कैंसिलेशन होता है इसलिए नहीं आ रही है आपको, बाकी तो बहुत तेजी आ रही है. अब ठीक है. So guys, as we all can see what we are facing the issues, this disturbing noises are coming, but it's okay, we'll try to take the class unless it gets even higher and it gets with the continuity. Anyways, we right now are having a few topics left with us that we can solve in upcoming some number of hours. So probably tomorrow we can take a class where we can finish the remaining part of this chapter, and I can take just 1 hour lecture and I can finish the remaining part of this chapter. But as of now I can see I can't do it. So its correct answer should be argon, then sulfur, then selenium, then I think this is also correct. B is correct. First ionization potential of sodium is 5.1, then the value of electron gain enthalpy of sodium positive will be. So see, sodium is required to give 5.1 electron volt to convert it into Na positive. and electron. If I reverse the equation Na plus electron, then what will happen? It will go to Na, and in that way 5.1 electron volt will be released. So the correct answer should be A. The increasing order of the first transition enthalpy of boron, phosphorus, so we have to first arrange them properly. We have boron, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Then meanwhile we have phosphorus and sulfur. So no doubt this is 3p3 and this is 3p4. So phosphorus is higher than sulfur. So wherever sulfur is shown higher, it will be incorrect. Sulfur than phosphorus is incorrect. Phosphorus and this could be correct. But right after comparing these two, what I find is fluorine cannot have lesser than that, because ionization enthalpy increases left to the right and decreases down the group, to top to the bottom, left to the right. I think D is the correct answer. So everything what I'm doing is just applying the proper Anyways, this is the last question for the day. From electron gain enthalpy and onwards, I'll be completing in upcoming class. I'll take another 1 hour lecture. This is our part 1 of the day. The next part will be covered into the next class that will be conducting mostly by tomorrow morning, I guess same time 11 o'clock. Okay, so be available over here, guys. We'll continue the remaining part of this session tomorrow. I guess this is from electron gain enthalpy. But before that, let's have one more question. There are some set of atomic number. Which of these may have expectedly higher second ionization enthalpy? So you know what? Sometimes we have to find out the Cr plus, Mn plus, Fe plus, so that we can know about what has to be done, what electronic configuration is already available, what will take, which one of them is more stable that we cannot extract out an electron without any lesser energy, like without higher amount of energy needed. This is argon, this is 4s0, this is 3d5, which is the most stable configuration we see. This is most stable configuration and require most amount of the energy. If we check out for the other, it will be argon 4s1 3d5. Easily this one electron can be removed out. If we talk about argon, it is also 4s1 3d6. This is easily removed out. This is argon, scandium, titanium, vanadium 3d3 and 4s1. Again, this can be eliminated out. The correct answer should be A. So from here, we'll try to cover in the next session, in our next class. हाँ हाँ बोलो, हाँ भी कर देना, मैं एक बार लिख देता हूँ ना बच्चों को, मैसेज दे देता हूँ, 5 मिनट कर देना, 5 मिनट्स में कर देना, डन। What is this noise here?